Alright, the goal for this video topic is to develop a composite that is asymmetric, not balanced, apply a delta T to it, and through the combination of contraction or growth and curvature, confirm that CompositePro's output is consistent with verified hand calculation. So to give you a brief overview of the problem we're going to do, here is a depiction of the laminate that we're going to build. The top ply is a 45-degree ply. It is 5/1000ths of an inch thick, as you can see here. The second ply is 10/1000 thick, and it is a 0-degree ply. We're going to use ply properties as we see here, roughly IM 73501-6, and I've already entered these material properties into a laminate, lamina, and we'll be using those properties to develop this laminate and look at the response at a total delta T of minus 400 degrees F. Now ultimately I'm going to skip ahead just a little bit. The hand calculations will be available to the user on the verification problems. It goes through all the transformation matrices and so on. The bottom line answer we're after is here in terms of a local stress state at the center of the top ply is what we've done in this example, and the local strain state at the center of the top ply. So I'm going to move this out of the way. Let's build our laminate. I'm going to go new laminate. We're going to call this the delta T example. Add apply. We're looking for 3501-6. Remember that the top ply was 5/1000ths thick at an angle of 45 degrees. The second ply was 10/1000ths thick at an angle of 0 degrees. We'll save that. Now if we go to laminate and we're looking for global and local stresses and strains, we can open our delta T example. Recall that our laminate loads were minus 400 degrees F. No other loads were involved, and we can calculate the local stresses in terms of stress, of course, at the middle. And if we calculate the two plies, here's the stress state in the middle of the top ply along this line. Here's the stress state in the middle of the bottom ply along this line. So let's go back and check this again against our hand calculations. And if I move this out of the way, you can see that minus 813 compression PSI versus minus 842 is very close. We have round off error in our hand calculations here. 2147 versus 2150 in tension for sigma 2, and a minus 2098 versus a minus 088 for the top ply is indeed a confirmation that our calculations are good. If we go to the strain state, for example, we're interested in that, we can calculate the strain state, and that is consistent with this set of calculations down here. 3E-6 versus 4E-6, minus 0.0038, minus 0038, and minus 0.0026 versus 0.0026. So we have a good confirmation that the delta T calculations are correct.